So this is part 2 of the Intro to Functions, Function Notation, Systems of Linear Equations video series. So we're going to look at graphing constant function, determine if ordered pairs are solutions to a system, and then look at solving systems by graphing, substitution, and elimination. So when we're dealing with f of x equals mx plus b, let's just remember that b is your y-intercept and m is your slope, and that we could have an equation that's just y equal b, then we know that's going to be a horizontal line. And if we have x equal b, then we know we've got a vertical line. So just to recap on some graphing, remember when you have it in a slope-intercept form, you want to start with your y-intercept, which would be -2, and then you want to apply the rise over run or the slope. So you're going to increase 1 since it's positive, go up 1, right 3 since 1 is positive and 3 is positive. So up 1, right 3, or down 1, left 3. And you've got your line. Over here, we're looking at starting at +5 on the y-axis, and then notice our slope here is -2, so that's understood to be divided by 1. So we're going to drop 2 or go down 2 to the right 1. Down 2, right 1, down 2, right 1, and then we're going to go ahead and draw our line. Let's look at another one. It may not, we'll start with the one on the right since it's already in slope-intercept form. So we're going to start at 1 on the y-axis and then apply our slope. And notice our slope. See that negative is just off to the side? That means it doesn't matter where that negative goes. It could go with the 1 or the 4. It's just identifying that the slope is negative. So we can just go down 1 to the right 4, or back to the y-intercept, we could go up 1, left 4. And then go ahead and draw our line. Over here, it's not solved for y, so we want to go ahead and do that. So I'm going to add 2x to both sides, and then I'm going to come down here, and that's going to be 5y is equal to 2x plus 9. And so that each side will be divided by 5. So you'll have y equals 2/5 x plus 9/5. 9/5 is almost 2, so we'll go somewhere right there, and then we'll increase 2 and to the right 5, or down 2 to the left 5. And that's not a good line, so let's try that again. And there you go. Or we could have, we have just horizontal and vertical lines. So let's look at this first part here. So this would be y equal -4. So remember, it's y equal, so it's going to hit the y-axis at -4. So that would be right down here, be a horizontal line at, so this would be y equal -4. And then we've got x equal 3. We'll draw both of those on the same graph, and that will be over here, x meaning we're going to cross the x-axis at 3. So we should see a vertical line, x equal 3. And then let's look over on these two. And we'll have y equal 2. So that'll be a horizontal line here. And we'll just graph this one over here. And that will be x equal -1. So we'll see a horizontal line or a vertical line depending on what it's solved for. Y equal a constant, then we're going to see a horizontal line. X equal a constant, we're going to see a vertical line. When we talk about systems of linear equations and we talk about graphing those, and what are we doing with systems, is we're looking for a solution. So a system is just more than one set of equations together, where you're just trying to find the unknown that satisfies So you're looking for the x and you're looking for the y. You're looking where they'll crisscross on a graph, or if they don't crisscross, if they're parallel lines, then that means there's no equation or no solution. So how do we decide if an ordered pair is a solution? And it's all about a substitution. So let's look at this first one. So I've got x plus y is 6, I got 4x minus y is 14, and I want to know if 4, 2 satisfies both of them. So I'm going to substitute 4, looking at the first one here, 4 in for x, 2 for y, 4 plus 2, 6 equals 6, check, it works for that equation. Let's try the other one. 4 times 4 minus 2 equals 14, 4 times 4 is 16, 16 minus 2 is 14, 14 equals 14. That is a solution to both equations. So it's a solution to the system. Let's look at this second one. I'm looking at 3x plus 2y equals 11 and x plus 5y equals 36. So I'm going to substitute -1 for x, 7 for y, hope that it equals 11. So this will be -3 plus 14 equals 11. -3 plus 14 does equal 11. Check. It works for that equation. I need to check the other one. -1 plus 5 times 7 equals 36. -1 plus 35 equals 36. -1 plus 35 is 34. So it doesn't equal 36. So it's not a system because it was not, it didn't show that it was a solution for both. You can't just check one, you have to check both. Let's look at the third one. So 5 times 2 minus 3 times 2 equals -6. And then 2 is equal to 2 minus 2. So over here, 2 equals 0. Well, that doesn't work. So we know that one's not going to work, which means it's not going to work at all, because 10 minus 6 is equal to -6. So 4 does not equal -6. So it didn't work for both of them. So it was not a solution to the system. All right, now let's switch to graphing. So when you've got equations, we're going to graph both and see where they intersect, and where they intersect would be the solution. That's what we're looking for. So I'm going to start with the y-intercept here, and I'm going to move up to 3 on the y-axis, and I'm just going to apply the slope. I'm going to drop down 5 and go to the right 3. And then I'm going to connect those. And I'm going to come over here and go at -3, and then plot the slope of 1/3. So I'm going to go up 1, right 3, up 1, 1, 2, 3, or down 1 to the left 3. And you'll see that they intersect right here, and that solution would be 3, -2. Both of these are solved for y, so I'm going to go ahead and start with the y-intercept. So that will be -4. And then I want to apply the slope, which is 3 to 1. So I'm going to rise 3, go up 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And then draw my line. Come over here, slope intercept at +3. Notice the slope here is -1/2, so I'm going to go down 1, right 2. I'm going to go down 1, right 2, down 1, right 2, and it will intersect each other. And it looks like right there at 2, 2. All right, this one's not solved for y, so we're going to go ahead and do that. And so I'm going to take this first one, subtract 5x. So I've got 3y is equal to -5x plus 9. Divide everything by 3. And there is one equation. So I'm going to start at 3 on the y-axis. and then I'm going to, remember, I'm going to go down 5, right 3. And with my graph, I could only get those 2 points on there. And then I want to go with the second one. So negative x plus 3y equal negative 9. I'm going to add x to both sides. So 3y is equal to x minus 9. Divide everything by 3. So y equals 1/3 x minus 3. Start at negative 3. And I'm going to increase 1, go to the right 3. It looks like they're going to intersect right there. And that point will be 3, negative 2. Another one where they're both in y-intercept form, slope-intercept form, because I'm going to start there at negative 3. My slope will be, it's negative 2 to 1, so down 2 to the right 1, or up 2 to the left 1. And then the same thing here, I'm going to start at 2. And it's like the same slope. So we know what happens when we have the same slope. We're going to have parallel lines. And remember, parallel lines, they have different y-intercepts, but the same slope. All right, next let's look at substitution. Substitution is another method that, depending on your format that you're given, substitution can be a bit of a little bit more challenging because it's heavily algebraic as opposed to graphing it or using elimination, which is we'll look at next. But since you know that one is solved for a value, this is a good indication that you could use substitution. So now that we know that y is equal to 6x minus 11, wherever you see a y in the other equation, you just substitute 6x minus 11. And now you're all in terms of x. So now I can solve for x. I'm going to distribute. So that'll give me negative 18x plus 33 equals negative 7. Like terms here, that's negative 20x. And then I'm going to subtract 33, and that'll give me negative 40. Divide by negative 20, x is equal to 2. Now that I know x is equal to 2, I'm just going to come right over here to that original one because it's solved for y. So 6 times 2 minus 11, that's going to be 12 minus 11, y is equal to 1. So over here, I'm going to put the solution. It is 2, 1. That would be the solution. Let's look at the second one. It's already solved for y, so I'm going to take what y equals, and I'm going to substitute it right here. So that'll be 5x minus 4 times negative 3x plus 5 equals negative 3. So see what I did there? I took what y equaled, and I substituted it in over here for y. Now I'm in terms of x, so I'm going to solve for x. I'm going to distribute. That'll be negative 4 times a negative 3x would be a 12x. Negative 4 times a positive 5 would be negative 20. It all equals negative 3. So that would be 17x minus 20 equal negative 3. Add 20. So 17x equal, that's negative 3 plus 20. That's going to be 17, which makes x 1. And then I'm going to come right back here. So negative 3 times 1 plus 5. That's negative 3 plus 5. So y is equal to 2. So 1, 2 is the solution. All right. Let's look at another one. here I know since y has a coefficient of 1, this would be the best one to solve for. So I'm going to solve for y here. And I'm going to add the 5x. So y is equal to 5x minus 2. Remember, you cannot combine those. Those are not like terms. So wherever I see a y over here, I'm substituting 5x minus 2. So negative 3x plus 6 times 5x minus 2 is equal to negative 12. So remember, I solve for y, and notice 5x minus 2 shows up over here for y. So negative 3x distribute plus 30x minus 12 equals negative 12. So this will combine to give me 27x. And when I add 12 over here, looks like I'm going to get 0. So x would be 0. And then when I substitute 0 over here, I'm going to get 5 times 0 minus 2. Y equals negative 2. So 0, negative 2 would be the solution to the system. Next, I'm going to actually do the same thing, solve this one for y. I'm going to add x. So y is equal to x plus 3. And then I'm going to take that and substitute it in for y. 3x plus 3 times x plus 3 equals 4. So this will be negative 3x, and this will be positive 3x plus 9 is equal to 4. Notice what happens to your x's. They cancel out. You're left with 9 equal 4. That does not equal. This is a no solution. So when you graph these two, they would be parallel lines. These next few we're going to look at solving by elimination. So this is a different method where you are actually doing what the method says. You're trying to eliminate a variable, and you can do that by adding or subtracting the equations, or you can create a multiple of one equation. But a very common way to do this is try to get one variable with the coefficients, one positive, one negative. That's a very convenient way, because then all you're doing is adding the system together. So let's look at the first one. X minus y equals 11, and then 2x plus y equals 19. Notice how I'm writing it. It's nice to write it vertically like this, because I can see, well, what happens if I add the two equations together? Notice what we have here. The y coefficients are negative 1 and positive 1. So when you add these equations together, you actually lose y. You just eliminated y. So 1x plus 2x would be 3x, and 11 plus 19 would be 30. And so divide by 3, and x would be 10. Well, now that you know that x is 10, you get to pick which equation you want to go substitute back in to solve for y. So I'm going to go right over here. I know x is 10. So this will be 20 plus y is equal to 19. So I'm going to subtract 20. So y is negative 1. So the solution to this system would be 10, negative 1. All right, let's look at another one. We'll look at this system here. Negative 6x plus 5y is equal to 1. So I'm going to set it vertically with the other one. And now that I'm writing it, I can see right here that x's would be the best one to eliminate, because one's positive and one's negative. So when I add those together, negative 6x plus 6x goes to 0. I eliminated it. Now, what's 5y and 4y? Well, that's 9y. What's 1 minus 10? That's negative 9. So divide both by 9, you're going to get y equal -1. Go back to either equation, it doesn't matter. So I'm going to go right over here. So 6x plus 4 times -1 equals -10. That's going to be -4. So I'm going to add 4. So 6x is equal to -6, so x is -1. So your solution is actually -1, -1. All right, let's look at the last one here. So 8x plus 14y equal 4. And then -6x minus 7y is equal to 28. All right, now we're getting into where we notice, all right, I've got coefficients of 8 and -6 for x and 14 and -7 for y. Nothing's the same. So this is where you're going to try to create a multiple. Now what I'm going to choose to do is make the y coefficients 14, positive 14 and -14. So since this one's already positive 14, I need to multiply this second equation, and I'm going to multiply it by 2. Why? Because 2 times -7 is -14, and that will then allow me to eliminate my y values. So I have to multiply everything in that second equation by 2. So 8x plus 14y equal 4, -12x minus 14y equals 28 and 28, what's that, 56? So I add these together, I lose the y's, I get -4x is equal to 4 and 56, that's 60. So divide both by -4, and that should be, what, -15? Now that I know x is -15, then I'm going to go back to one of these here or here and solve. So I'm going to go to the one over here. So -6 times -15 minus 7y equals 28. And this will be 60 and 30, so this will be 90. So when I subtract 90 from both sides, so then I'll have over here -7y is equal to -62. So that's just a little, 63 would be 9. So that would be 8 and something. That one came out to be more of a fraction. Not what I wanted on that one, but that's okay. It would be -15 and 8 something as the result. Again, with elimination, let's look at this one right here. So that should be x there. So -4x minus 2y is equal to 14. And -10x plus 7y is equal to -25. So on this one, I'm going to end up multiplying. Looks like I'm going to have to pick. And so do I want to eliminate x or y? So I'm going to actually have to do both of these by a certain number. And so I'm going to multiply, I'm going to eliminate y. So I'm going to multiply this one by 7. And I'm going to multiply this bottom one by 2. So 7 multiplied to each of them. So that's -28 x minus 14y is equal to, what's that, 70 and 28. So that's 98. 70 and 28, I get 98. And then over here, I've got 2 multiplied by all of those, so that'd be -20x. And 14y and -50. So if I add those together, I should eliminate y. I should get negative 48x, and then 98 minus 50 is 48. So x is going to be negative 1. And so then go back to, I'm going to go back over here. So negative 10 times negative 1 plus 7y is equal to negative 25. So this will be 10 plus 7y is equal to negative 25. And then when I subtract 10, I'm going to get 7y is equal to negative 35. And so y is equal to negative 5. So the solution would be negative 1, negative 5. So let's look at one more. Let's look at this one here, and then we'll end. So 2x plus 8y is equal to 6, and negative 5x minus 20y is equal to negative 15. So I need to pick which one I want to eliminate. So I'm going to multiply this top one by 5 and the bottom one by 2 so I can eliminate x. So just remember you have to distribute to everything. So that would be 10x plus 40y equals 30. And then the 2 multiplied to everything. So that would be negative 10x minus 40y is equal to negative 30. So I actually lose, notice I lose my x's and my y's. So I get 0 is equal to 0. And this would be infinite number of solutions.